Goal for today is to write the equation of a circle in standard form. Yesterday, you were given information to write the equation of a circle by finding the center and then finding the radius and then just substituting the information into the equation of a circle. Sometimes you're going to see an equation of a circle where the quantity of x minus h squared is expanded and the quantity of y minus k squared is expanded. And what we have to do is undo that expanding and to create these perfect square binomials. I've outlined a kind of step-by-step process that we'll go through here. As I complete each problem, I'll be going through each step and explaining this process. So in example 1, here's the equation of a circle, not in standard form. The first step we're going to do to get this equation of a circle in standard form is we're going to group the x's and leave a space. We're also going to group the y's to leave a space, and we're going to move the constant to the other side of the equation. When I did that, you'll notice I've also left 2 spaces on the right-hand side of the equation, because whatever I add to one side of the equation, I have to add to the other. So when I group the x's, you'll see that I have a binomial right now of x squared and 16x. I have to find some number that if I add to that expression, I'm able to factor it. And when I factor it, I want to create a perfect square trinomial so that it factors to be a binomial squared. We did this back in chapter 5 when we solved the equations for quadratics by the process of completing the square. To complete the square, we look at b. And in this case, for the x's, b is 16. We take 16 divided by 2, which is 8, and then we square 8. Once we square 8, we get 64. So I'm going to add 64 to this left-hand side of the equation. However, to keep the equation balanced, whatever I do to the left-hand side, I also do to the right-hand side. I'm going to do the same thing with the y's. I now have a binomial with y's of y squared minus 22y. I want to figure out a value that if I add to that, I'm going to create a perfect square trinomial that will factor to be a binomial squared. Again, we're going to complete the process of completing the square. I'm going to take 22, I'm going to divide it by 2 and get 11, and then I'm going to square it to get 121. And I'm going to add 121 to both sides of the equation. Now, if you go and factor x squared plus 16x plus 64, you're going to get x plus 8 quantity squared. If you factor y squared minus 22y plus 121, it will factor to be y minus 11 squared. So you can see this now looks like the equation of a circle. I'm also going to add 20 plus 64 plus 121 to simplify the right-hand side of the equation and get 205. So this is our equation of a circle in standard form. We can pull the center and radius from that equation. The center would be the ordered pair, negative 8, 11. Remember, think opposite when you're pulling the numbers out of the equation. And in our equation for a circle, this is the radius squared, so our radius would be the square root of 205. Let's look at another example. Again, here's the equation of a circle, not in standard form. To put the equation of the circle in standard form, I've outlined this step-by-step process to make this as easy as possible. We're going to group the x's, we're going to group the y's. I'll also move the constant to the other side of the equation. And just like before, I'm going to leave spaces because I want to figure out what values I can add to each of the expressions for x's and y's so that they'll factor. Again, right now we have a binomial of x squared minus 12x. I want to add some number to create a trinomial that'll be a perfect square trinomial. To do that, I look at b. b in this case is 12. I take 12 divided by 2, which is 6, and I square it, and I'm going to add 36 to the left side of the equation. I'm going to also add it to the right side. I'm going to do the same thing for the y's. I look at b. b is 8. I'm going to take 8 divided by 2, which is 4. Square 4 to get 16. And I'm going to add 16 to both sides of the equation. At this point, I'm able to factor this trinomial of x squared minus 12x plus 36. I'm also able to factor the trinomial of y squared plus 8y plus 16. These, since we use the process of completing the square, these are perfect square trinomials. So I have the quantity of x minus 6 squared plus the quantity of y plus 4 squared, and I simplify the right-hand side of the equation to get 20. Again, I can pull the information of the center and the radius out of that equation, and the center is 6, negative 4. Always think backwards. And the radius is the square root of 20, which in simplest radical form is 2 root 5.